Hello everyone, this is Dr. E, and for today we're going to be working on similarity, specifically on the lesson on ratio and proportion. In mathematics, it's not only important to master the operations or the four basic operations and also the multiplication table, writing and understanding mathematical notation is also important, and that is what we're going to be working on in this lesson for today, which is working on similarity, specifically on writing ratio and proportion in some word problems involving mathematics. So for this work, we're going to be changing or converting verbal statement into its correct fraction form, specifically on ratio, because in mathematics, ratio is synonymous to a fraction because it is the quotient of two quantities. And when we're talking about quotient, it is the operation of division, also represented as a fraction. So if we have a ratio of 1 to 2, we can write this particular ratio as a verbal phrase like 1 to 2. We can also write it in fraction form, similar to 1/2. Or we can also write this ratio using a colon, similar to the three examples that you are seeing. All of them are basically notation or how we write 1 to 2 when it comes to a mathematical expression. So take note of the numerical value that you are seeing on the first item in your statement, because that will be your numerator and then the denominator when you're writing ratio in fraction form. For example, if we're going to write 12 to 17 in fractional notation, we write it simply as 12 all over 17. However, if we write the ratio of 12 to 17 into 17 all over 12, this is not a representation of the verbal statement ratio of 12 to 17, because 12 needs to be your numerator and 17 is going to be your denominator. So to write 17 all over 12 correctly, it should have been ratio of 17 to 12 to be able to write a fraction similar to this one. So it's important that when we are writing ratio in mathematics, we are writing it properly, because writing or finding the correct answer in some word problems when written in a different form will not help you in solving the word problem that you're working on. So if we need to write this particular ratio in its simplest form of fraction, let's say we have $15 to $10. So since $15 is the first numerical value that we are seeing, that will be our numerator and the denominator will be $10. And by simplifying this particular expression, so from $15 all over $10, since we're simplifying the ratio in its simplest form, let's drop the dollar sign and just focus on 15 all over 10. And let's simplify this by factoring. And the factors of 15 would be 5 times 3, and the factors of 2 would be 5 times 2. And in this way, we'll be able to cancel out the 5s. So we now have 3 all over 2 as the simplest form of our fraction from $15 to $10 in our ratio. So this is how we use our skill on simplifying fraction by factoring, so that we'll be able to simplify our ratio on its simplest form. And this is also true when we're working with problems similar to this geometry problem, wherein we are given a rectangle given by its length and its width. And in this case, we have 7 feet for the length of the rectangle and 5 feet for the width of the rectangle. What we need to do is to A, find the ratio of its width to its length, and B, find the ratio of its length to its perimeter. So if we're going to work on the first item or the first problem in this geometry, this rectangle that we are working on, says here that we need to write the ratio of the width to its length. So that means we're working on width all over the length. And in this rectangle, we have width as 5 feet. And we have length of 7 feet. And by getting rid of the unit of measurement, the simplest form of our fraction would be 5 all over 7. And this is how we write this particular ratio in fraction form. So we have 5 feet all over 7 feet, getting rid of the unit of measurement so that we can have a value of our ratio in fraction form similar to 5 over 7. Now for the second problem, it's going to be a little bit different because if you notice, we are working on the ratio of the length to its perimeter. But the problem is we don't have the perimeter value of this rectangle. So that means we need to find the perimeter of this rectangle on our own by using the formula for finding the perimeter. So we know that this is 7 feet and we know that this is 5 feet. And to find the perimeter of a rectangle, we need to find the length of the sides of your rectangle. So if this is 5 feet, we know that it's congruent to the opposite side. So this is also 5 feet. And if this is 7 feet, this is congruent to the other side or opposite side. So this is 7. So to find the perimeter, all we need to do is to add twice of 7 plus twice of 5. And we'll have 14 plus 10. So the perimeter of this rectangle is equal to 24. So that means we now have the perimeter and we also have the length. And the length is equal to 7 feet. And we are now ready to write the ratio of this rectangle from length to its perimeter. So that will be length first all over perimeter, and we know that our length is equal to 7 feet all over 24 feet, and by simplifying the fraction, we now have 7 over 24 as the fraction form of the ratio of the length of this rectangle and its perimeter, which happens to be 24 feet. And by simplifying our ratio, we now have 7 over 24 as a representation of the fraction of the ratio of the length to its perimeter of this rectangle. So that's why it's important that we know how we're going to write the numerator and the denominator of our ratio in fraction form to avoid confusion on the fraction that we are associating our ratio with. So in this problem, we are working on a word problem involving a triangle and its extended ratio. So according to the problem, the length of the sides of a triangle are in the extended ratio 3:5:6. Now what we need to do is to find the length of the side of our triangle given that the perimeter is equal to 98 units. So to be able to answer this problem, we need our visual, and since we are given the extended ratio of 3:5:6, and this is in association with the perimeter of a rectangle. So this is our rectangle. So let's say this length is 3:5:6 unit of measurement as indicated to our extended ratio. And the perimeter of our triangle is equal to 98 units. And what we need to do is to find the value of the length of the sides given this information and our ratio. And to be able to do that, we're not just going to add 3, 5, and 6. We are going to write out 3x is to 5x is to 6x since we're working on the x value of the length of your triangle based on its ratio. So by replacing our numerical value into an algebraic expression as 3x, 5x plus 6x, we can now write the equation that will help us find the value of our x. Since the perimeter is the length of the sides, we're going to add 3x plus 5x plus 6x equal to its perimeter that we know is 98 units to find the value of our x's. And we know that 3 plus 5 is 8 and 8 plus 6 is equal to 14. So we have 14x equal to 98 units. And by dividing both sides by 14, x is equal to 7 units. So this is the value of our x variable that will help us find the value of our side lengths of this particular triangle. So by solving for x, we are now one step closer to our side lengths because we know that the ratio or extended ratio is 3 is to 5 is to 6, which we can transform into 3x, 5x, and 6x to match the description of our triangle with a perimeter that is equal to 98 units. So to find that value of x, we added those three x's, which is equal to 14x, and divide both sides by 14 so that x is equal to 7. And by doing so, all we need to do now is to just multiply our value of x with 3 right here, which is 7 times 3 is equal to 21. This is going to be 5 times x equal to 35, and 6 times 7 is equal to 42. So now we have the side lengths of our triangle given by the value of x that we just found using algebra. And since we are working on word problems and using algebra in solving for our triangle, let's work on how we solve proportions when it comes to an equation. So the operation that we're going to be using in connection or in relation to a fraction is cross multiplication. And in this particular equation, we're seeing fraction equal to a fraction, and every time you are seeing an expression or equation similar to this one, we're going to be using the method or the process of cross multiplication. And in cross multiplication, we have terminologies that is associated with the two fractions that we are seeing. So these two fractions, or the first diagonal of our two fractions, is what we call as the extremes. And the second diagonal is going to be our means. And when we convert 2 over 3 and 4 over 6 into 2 is to 3 equal to 4 is to 6, the reason why it's called extremes is because those are the two values on the opposite side of our equation, and the inside will be our means. And now, with this in mind, we can now use the cross multiplication operation for 2 over 3 equal to 4 over 6, which means we're just going to multiply 2 and 6 and 3 and 4, and we know that both of them is equal to 12, which satisfies our equation. So the two fraction may look different at the beginning, but we know by cross multiplication, we're able to prove that they are the same. So we have the extremes and the means as our terminologies that we use for those values so that cross multiplications or cross products will occur. So we have the means and the extremes for those fractions or those two fractions that we're using, and we're going to use that, in solving for problem number 1 and problem number 2. So let's start with number 1, and we know that we can use cross multiplication in this problem because we have a fraction equal to a fraction. So if I have 6 all over x equal to 5 all over 4, by multiplying the extremes, 6 times 4 is equal to 5 times x, which gives us 24 equal to 5x, And by dividing both sides by 5, we now have x equal to 24 all over 5. And we cannot simplify this anymore unless we want to change it into a mixed number, which is not what we're doing because we just need to write our answer in fraction form as 24 all over 5. So we multiply 6 and 4, we multiply 5 and x, and we simplify our equation. And now we have 24 over 5 for problem number 1. And for problem number 2, we have y plus 4 all over 9 equal to y over 3. So we're going to be using the same process. We're going to do cross multiplication and solve for the variable y. So we have y plus 4 all over 9 equal to y all over 3. So by cross multiplication, we have 3 times y plus 4 equals 9 times y. So now, by distributive property, we'll have 3y plus 12 equals 9y. And by subtracting 3y on both sides, we'll have 12 equal to 6y. And by dividing both sides by 6, we know that y is equal to 2. And now we have the value of y that we're looking for using cross products or cross multiplication. Multiplying the extreme equal to the product of the means, and we'll have y equal to 2 using algebra. So those are the operations that we are using when we are working with fractions and ratio, similar to what we have just finished or completed in these two problems. So your Numberbender challenge of the day would be to find the side lengths of this triangle, given that the perimeter is 90 centimeters and the extended ratio is 2:3:5. So use your algebra skill and your geometry skill to be able to find the side lengths of this polynomial. And this is how we answer problems on ratio and proportion when it comes to word problems, similar to what we have worked on in this lesson. So make sure in geometry that you are not just mastering the skill or operations that we are using to solve for the values of x. We also need to be able to understand mathematical notation, or how we write things in mathematical equation correctly. So this is Dr. E. Practice, because that will really help you in your confidence when you're working with problems similar to what we just did. See you again next time. Bye!